Hello, everybody. Welcome back. Thank you all for joining me again with our multi-part lesson on functions and derivatives. My name is Pathman Math, and today we are going to extend our knowledge on functions. Like I discussed last week, explaining what a function is a equation that we establish to help us graph. Okay? So our functions basically create what a graph looks like. And I'm needing to establish some more information here for you guys before we move on to the derivative portion of the lesson here. Because the derivatives deal heavily with the graphing part. And last week, all I did was discuss the introduction to functions. We didn't really cover too much on what the graphs fully look like, what all the values inside the function really mean. So I'm going to expand your knowledge a little bit more on what what encompasses a function before moving on to the derivative portion. So, if you remember from last week, the function that we establish is f of x. When you put the x in parentheses here, it's f of x, or a function of x. Okay? Because what we do is we plug in x values into this equation that we have, solve it, and then we get the y value for each coordinate point on our graph that we are working with. Because a graph is basically just a series of coordinate points that you then connect with a line. So, function of x, or f of x, equals mx plus b. Now, last week I explained that m here and b here are just two constants that help dictate our function, which is true, but there's a little bit more in depth into what those values actually are. So, let's start with b here. B is what is called our y-intercept. Now, by intercept, what I mean is this is the part of the graph where it crosses through the y-axis. Now, what I mean by y-axis is the up and down part of a graph, or a coordinate plane. And then the horizontal part, the side to side, is the x. So this is the x-axis, this is the y-axis. The y-intercept is where our graph crosses through the y-axis. So say we have a line or graph that looks like this, okay? This right here, this point, is our y-intercept, okay? And the way you will write this out in coordinate terms is 0, comma, b, okay? Because this is the x value, this is the y value, okay? And since it crosses through the y-axis, this right here is our 0, 0. This is where it's the x is going to be 0. So 0, comma, b for our y-intercept, because we have some value that the line crosses through on the y-axis, and that is our y-intercept. Okay? So let's say we have this graph right here. This right here is our y-intercept for this one. Let's say we go all the way up here. That's our y-intercept. Whatever point, whatever y value for the graph crossing through the y-axis, that is our value for our y-intercept. That's our b here. Now, our m here, like I said, it's another constant. Our m is our slope. Okay? Another way to view this is it's the rise over the run. Now, what I mean for this is, say we have a graph that looks like this. Now, real quick, most graphs continue forever in both directions, okay? So you need to make sure you add your arrows onto your graph, because unless we establish that the function ends at this point and this point here, then that graph's going to go on forever, whichever direction we're going for it, whether it is a higher tiered power, such as x squared, x cubed, x to the fourth, so on and so forth. The graph goes on forever unless we establish that it has specific stopping points. Okay? So, M is our slope, it's our rise over our run. And what that basically means is we have 2 points on our graph, and what we are trying to do is find the constant value that allows our graph to move between those 2 points. Okay? Now it's our rise over our run, so it's our rise and our run. Okay? How high does it go and how far does it go between the 2 points? Now, in order to find what that value is, the rise over run, you establish the left and right numbers, okay? So, this is our left point. This is our right point. And for the right point, it's going to be written as y, not y, my bad. Back up. X sub 2, comma, y sub 2. Okay? X value and Y value, but we're establishing that this is our right point, because what we're trying to do is go our rise over our run, how to get from the left side of the graph to the right side of the graph. Because again, it's like you read a book. You read from left to right. You're doing the same thing with the graph. You're reading left to right here. So our right point is going to be stated as x sub 2 and y sub 2. Put a little 2 down at the bottom. And then our left point, yes, is going to be x sub 1, comma, y sub 1. And now using these 4 values, the 2 x's and the 2 y's here, we'll establish how to solve for our slope. So rise over run equals, and we have our y sub 2 minus our y sub 1 over x sub 2 minus x sub 1. So we plug in the values of our 2 points here, plug in our 2 y values on top, our 2 x values on the bottom, and you do the right minus the left for both the top and the bottom. And then, once we perform the operations here, we get our slope. Okay? Now, sometimes your slope is not going to be written as a fraction. It's just going to be written as a whole number. So say we have m equal to 2. Basically what this means is we have a rise of 2 over a run of 1. Because dividing by 1, same as multiplying by 1, it's still going to be the same value. So our rise is 2, our run is 1. So for every point that we move, we're going to go up 2 values and over 1 value. Up 2 values, over 1 value, up 2 values, over 1 value. Okay? And let's say it's a negative 2 over 1. What this means is we're going to go down 2 levels over 1, down 2 over 1, down 2 over 1. Okay? So if it's positive, it goes up. If it's negative, it goes down. So this is the general information on dealing with a function and how it relates to a graph. Okay, so I'm going to go through a short example here on how to solve for the slope of a table of values that list what the points are for our graph. Okay, so go ahead and erase this. Now we have our x, we have our y, which our y is basically our f of x here. We are plugging in an x value and getting a y value or an f of x value. Now remember, from last week, we used 5 specific values. We used -2, -1, 0, 1, and 2. You establish 0 because you need to know what your y-intercept is, and then you have 2 values on either side of the y-axis. That way you can fully see how this graph is going to look. So, I'm going to establish a function f of x equals mx minus 2. Okay? And write in our x values here. We are going to need to solve what m is. Okay? So we've got our 5 values here. Now remember, the y-intercept is always in the form of 0, comma, and then whatever that b value is. So here, where our x is, we can already establish that our -2. Okay, so that is our y-intercept right here. Now the other values that we've got, I am going to say we have got -7, I had the values in my head. Give me 1 second here. 3 here. Then -12 and 8. All right. Making sure got all the information up here in my noggin. Sometimes things get a little jumbled around as I'm trying to remember because I don't have the notes in front of my head. My notes are all up inside my big old noodle here, my big head. So with our table of values here, we are needed to establish what our slope is. Okay, so real quick, just going to do a general image for our graph. Okay, so y, x, and it's 0, -2, so our y-intercept is going to be down here somewhere. We have 1, 3, so up here somewhere, and 2, 8, say somewhere around up here. And we have -1, -7, so down there, and somewhere down here for the other one. And then we connect it as best as possible. And do not forget your arrows because remember, unless we establish that the function ends at a certain point, this graph will go on forever in both directions. So, general idea of what the graph is going to look like. I know it's not the best, but just good visual. Now, to solve for our slope, remember, it is our rise over our run. In this case here, y2, our right point that we're choosing, minus y1, our left point that we're choosing. Same for the x sub 2 here, x2, minus x1. So right point, left point. Now, let's say we've got, this is our left let's go with these two here, the two negatives. Let's go with the two negatives, give it a little bit more of a challenge with needing to deal with these negatives. So our left point is going to be, I'll say that this is our left, and this is our right. This is our left, this is our right. So we need to set up our numbers. So right point, we have -7 minus -12 over -1 minus -2. Okay? Now I needed to put the two values for the left or the right point in parentheses because looking at this, we have a double negative. That's the first thing you should see is that there is a double negative here, and a double negative makes it positive. So now we've got -7 plus 12 over -1 plus 2. And what you can do is switch the values around because it's still going to be the same values. When you're doing subtraction and addition, you can move the position of the numbers, and it's still going to give you the same thing. It just cleans it up a little bit because this right here, that's a lot going on there. So I'm going to say instead 12 minus 7 over 2 minus 1. That looks a heck of a lot cleaner than all of these signs here, all these negatives and double negatives and stuff. Looks so much cleaner. And it's a little easier to read because now we have, instead of saying -7 plus 12, we have 12 minus 7. That's real easy. That is a big old 5. And then we have 2 minus 1 instead of -1 plus 2. We have 2 minus 1, so that's 1. So we have our rise over our run, but for sake of cleanliness, our m is equal to 5. So instead of our function being f of x equals mx minus 2, we erase that, and we write in a 5, and we have our equation here. F of x equals 5x minus 2. Boom, right there. So we have our equation, our function, for our graph here with our table of values that we solved by using rise over run equation here. We got our slope. Now, for higher tiered powers, okay, what I mean by that, higher tiered functions, what I mean by that, clean all this out. This right here is what's called a linear function. Okay? Now, for a higher tiered value, a higher tiered function, we have ax squared plus bx plus c. And this is a quadratic function. Okay? Last week, I gave a basic example of a quadratic function. Okay? And it was just an x squared and a constant establishing our parabola that we had. So, for a linear function is like this. For a quadratic, looks like this. And we need to have all these extra terms here, these extra values set up, because you're trying to establish every point that is inside of the graph itself. So you need to add in more terms. And The reason for us going further with this is dealing with derivatives. You have to handle every part of the function, okay? Now, we have our values here. Essentially, our slope is going to be dealing with the a combination of our A, B, and C here for it. And basically our slope is going to be a linear equation, a linear function. So that's going to be going further on. And then we've got other higher tiered functions here. Ax cubed plus bx squared plus cx plus d. And it keeps going on and on and on and on for that. The higher tiered powers that you go with. And for what this is called is a cubic. And essentially a cubic looks like an N-shaped graph. Because there's so much going on with all of these here. Because essentially, when you get to the negatives and stuff, it starts throwing the values all over the place. And then going further out on the positive side too. So we've got these different tiers of powers. And next week, I'm going to go onto the quadratic. Okay. This week was just covering linear and getting some more introductory stuff going through because this is a multi-step lesson. There's a lot to cover, but it's rather easy to deal with. Okay. So trying to break it up as best I can. That way I'm not overloading you guys with so much information. So we've got linear down. We had introduction with it. We touched a little bit on the quadratic here. I'll go more in depth into it next week. I'm going to forego going onto the cubic because we won't need to worry about that too much. Dealing with graphing quality stuff. But when we get to actually talking about the derivatives, then I will discuss more on the cubic. But the big functions that you typically deal with are linear and quadratic. You go into cubic a little bit, but for the most part, you're mainly dealing with linear and quadratic until you get to higher level math. So next week, I'm going to cover quadratic, touch base with you guys on that, and then once we've got more information on the quadratic, then we will move on to the derivatives. Okay? So I appreciate you guys sticking with me. Thank you all for just giving me the time of your day to listen to the spiel, the chaotic craziness that runs through my head. I appreciate all you guys. If you have any comments, any questions, any requests for lessons, feel free to message in the comment section down below. I will greatly take so much pride and joy in responding to you guys. So much appreciation for that. So, like I said, any comments, any questions, any requests, concerns, anything like that, go ahead, comment down this comment section below. And I will catch you all next week as we continue on with our functions and derivatives multi-part lesson. Hope you all have a wonderful rest of your day, and I'll see you all in the next one. See ya!